Hello everyone and welcome to Kerbal Space Program. This is version 0.21.1 and we are going to build a space plane. We'll start with this Mark 1 cockpit and go on from there. We'll be using turbojet engine to get us high in the atmosphere and maybe even get out of the atmosphere, and we'll see how that goes, but this is the one you want to be using for space planes. The basic jet engine is great for low altitude things, maybe for engine for a boat or car or vertical takeoff plane, the vertical part, but turbojet engine is much better higher up in the atmosphere, so we will be using that, and only one engine because we will be making a light plane, not too heavy, and the engine needs jet fuel, of course, so we'll be using this this fuselage, and we want to make a space plane single stage to orbit, so we will need rocket engines also, so we have to put on some oxidizer tanks, so I think that, well, that's too much. We don't need that much. Let's put on these smaller tanks, and like so. I try to place these tanks in the middle of this fuselage so that when the fuel drains from the tank, it won't shift the center of mass too badly. What I did there is I put a fuel line, had symmetry mode on, so that both of these tanks will the fuel will flow to the center fuselage, and there it will go to the engine using the fuel. Now I'm going to build this frame of sorts. What we are going to do here is we are going to see the center of mass and how it will change when the fuel drains. The center of mass when the tank is full is here. I'm going to mark the place with this strut, cubic strut. Just so that we know, and then we need we need to figure out where the center of mass will be when the tank is empty, so I'm going to build this temporary thing to help us. I'm trying to place the fuselage exactly like so, and then we need to figure out how much this whole thing weighs. when it's empty, and we can see that this Mark II fuselage has a dry mass of 0.2 tons, and these tanks have dry mass of 0.125. So we have two of those. It's 0.25 and 0.2 to 0.45. Now we need something that's close to that weight. Trying to find something. Well, we can use two of these. It's not exactly, but it's close enough, I think. I'm placing these here in the middle, so we can guesstimate where the center of mass will be when these are empty, and it's right there. So I'm going to mark this place also with a strut, like so, and then we can get rid of this thing here, and okay, like so. Now we know that the fuel, when it drains, the center of mass, which is right here, will move backwards to here, and we need this information for the next part, which is wings. The center of lift is important that it is always behind the center of mass. When the center of mass moves backwards, and if the center of lift is here and the tank dries and the center of mass moves here, the plane will become unstable and unflyable. So what we need to do is make our wings in a way that the center of lift will be behind this point, so we won't have any problems in any part of the flight, in the takeoff or the landing with empty tanks. I'm going to start designing my wings and put some wing parts together and see where we can see in real time that the center of lift moves backwards when we place these wings, but it's not moving enough. So what we need to do is put a tail to the plane, maybe use these wings like so, and now we can see that we are almost there. This is almost perfect. But one thing we are still missing is control surfaces. It is a plane after all. So I'm going to place these control surfaces here on the tail, and now we see that it's moved backwards too much. This is not good. It can be slightly behind the center of mass, but not too much. If it's too much back, then the plane doesn't want to lift its nose or or anything. It just wants to fly straight, or if it flies at all, it wants to fly straight, and we don't want that, so we need to move it back forwards a bit. Even though the looks aren't essential, they are important nonetheless, so I'm going to cover up these ugly black holes with these wings, and now we see it's still behind. We'll place these control surfaces right here, and what we can do is we can use the canard wings. Use the canard wings and see if that helps us. So a little bit, maybe if we place that wing right in the nose, it's closer. Let's see if, okay, this moves it quite a bit. Rotate the part, and I think this is just about perfect. Now what we need for our plane is a rudder. Every plane needs one. I'm going to put one right here. Actually two. It's a twin rudder, like so. And this turbojet engine needs air intakes, and what I'm going to do is I'm going to use this little trick I've been using with almost every one of my planes. I'm going to place one cubic strut here, and then I'm going to put a intake. I'm going to put a intake on that strut. Alt click to copy the part and and place it on the strut, but it doesn't want to play ball, so I'm going to try again. Sometimes you need to be patient with this. But now we have nice air intake pair. We can copy that part and place it here. Now we have 4 intakes, which is nice, but I think I'm going to double that and use 8, like so. Okay, now we want to place the rocket engines. These are so small, so light that they won't mess our center of mass. Maybe a little bit, but it's not too bad. Okay, this is starting to look like a plane. It has engine intakes, rocket engine, fuel for both engines, and we will be strutting this plane now. We don't want any wobble or any kind of movement if we can avoid it. And we can place these struts, run them like so, and then have one for the wingtip and one for the tail, and I think that will be rock solid. Maybe have struts going to the tail also. I think that this plane won't wobble a bit. This should be good. Okay, now one thing that it's important to check is that center of thrust. This plane has engines symmetrical to the center line. The one jet engine right here in the middle, the center line, and two rocket engines here, also symmetrical in regard of the center line. So we have the center of thrust right here in the middle, and that's where we need to have it. It needs to be right behind the center of mass. If the center of thrust is above the center of mass, it tries to push the nose of the plane down, and if it's below, it tries to push the nose up. Same thing if the center of thrust is to the left, it tries to spin the plane right, and if it's to the right, it tries to spin the plane to the left. This is what happens, for example, when we have two jet engines in the back and we run out of intake air, and one of the engines flame out, the other will be still running, and so the center of thrust will move to the running engine, and that will spin the plane. The further it is from the center line, the engine, I mean, the more violent the spin will be, or if the engines are running at maximum power, then the spin will be very violent, and maybe you cannot recover from that. But since we have one engine only, and the center of thrust is right here in the middle, we won't have any problems with that. Even if we have an engine flame out at some point, the plane will keep on going straight. If it's just a little bit off center, you may be able to get away with it, because the plane has these control surfaces here in the front and in the rudder, and they will try to keep the plane going straight. Now with the new version, all cockpits have the SAS or ASAS functionality built into them, and the plane will try to steer itself forward. Also, the plane has some control, because the jet engine has thrust vectoring. It will maneuver itself with the engine a little bit, and also the cockpit has some torque, the magic torque, if you will. It can it can also rotate itself and steer itself with the torque from the cockpit. The new SAS and ASAS parts, these used to be flight computer parts, but now they are reaction wheels, and they provide torque also, but for this plane we don't need these parts. They are just extra weight. The control from these surfaces and the thrust vectoring and the magic torque from the command pod is plenty of us in the atmosphere. When we are out of the atmosphere, these control surfaces don't work anymore, of course, but the torque from the pod is enough to turn the plane. This won't be too heavy, so we don't have any problems with that, and we don't want to add any weight, so these can be now for now. All right. One very important thing is action groups. For a Spaceplane or SSTO plane, we want action groups for the jet engine. Toggle that. We want one action group for the rocket engine, so we can toggle the rocket engine on and off, and one for these air intakes, so we can close them when we don't need them anymore. We are high up in the air and the jet engine doesn't work anymore, so we can close the air intakes, so they won't produce any drag, and we can go glide or coast more easily. One thing I almost forgot was that now the command pod or cockpit, it uses electricity, so we will put on this generator. It generates plenty of electricity. We need one. It's right there. And then this plane is ready to fly, except for one thing. It needs a landing gear. Oh, and it needs a ladder for our pilot to climb out of the plane. And rotate it a bit. And now what I am going to do is I'm going to make this so that we have one wheel at the back. It will protect the engine from hitting the ground when we lift off. It will work nicely, and then we use two landing gears in the front. One thing I can show you right now is the center of mass seems to be moving back and forth when I move these landing gear, but that's an illusion. Don't pay any attention to that, because even though these wheels are indicated to have a half a ton of mass each, they are massless when they are actually on the plane and we lift off. They won't affect our center of mass at all. So I usually put on those landing gear last, because that way they don't mess up my perception of the center of mass. Now we can see that the tail is kind of higher. The plane will sit on the landing runway almost like this. It means that it has angle of attack on the wings right away. So when we throttle up, plane starts to move forward. It has some lift already when it's moving really slow, but this can cause problems because we have lift here in the back, and when we gather speed, the tail will lift off first, and so the plane will run like this. Only two wheels touching the runway, it becomes more unstable, and if it rolls either side, only one wheel will be touching the runway, and that's a very unstable position. So we will need to lift off before that roll happens. We have so much wing that I think we can lift off at the really slow speed, but we'll see. The same thing applies when there's another way around. Let's imagine that this is the front of the plane, and here's the tail. Front of the plane has only one wheel and tail has two, like a fighter jet or something like that. And when the plane starts to roll the runway, and the lift from the wing in the back starts to lift the rear end of the plane up, only this one wheel remain in contact with the runway, and it's a unicycle. Then it's really easy to roll and crash. A lot of people have problems taking off with their planes, and if the reason isn't somewhere you forgot to put on symmetry mode or something like that, the plane is asymmetrical, then the reason is almost every time it's the wheels are too much uneven. They should be close to the same level to prevent that thing that I just told happening. But now I think the plane is ready. We can name it KG Burrow Single States to Orbit Mark 1. Save it. And one last check. We have all these like we want them to. We have fuel, we have fuel lines, action groups, engine, wings, ladder, and electricity. Yes, Thanks for watching my tutorial. You can check out the part 2 where I fly this plane and take it to orbit and back. But yeah, thanks for watching and see you next time.